Properties of exponents to the 0 power. So we read this here, x to the 0 or x to the 0 power. All right, so when we have something to the 0 power, how do we handle that? So again, when we have the exponent of 0, we say it is to the 0 power. The property is as follows. X to the 0 equals 1. Remember, anything times 0 is 0, but anything to the 0 power is 1. But we must provide that x itself is not 0. You will not anywhere in algebra see 0 to the 0. That's not something you will see. So don't worry about that. As long as you don't have 0 there, you can raise that thing to a power and get 1. All right? So what this means is anything raised to the 0 power is 1. And I'm being a little loose with that there because it cannot be 0. Anything other than 0. All right? So here, if I look at this, x to the 0 power is 1. It's really that simple. X to anything to the 0 power is 1. So here, y beside it here, y, this one over here, y to the 0 power is what? 1. Again, anything to the 0 power is 1. So look at the next one, 2m. Now look, here's where you got to be careful. You have 2m, that's two factors there. What's being raised to the 0 power here? Well, because it's in parentheses, all the stuff in the parentheses is being raised to that power. So if that's the case, it's all raised to the 0. Anything raised to the 0 is 1. So likewise right here, it's in parentheses. So guess what? It's all raised to the 0 power. So therefore the answer is simply 1. Right? So the key there is what's being raised to the 0 power. On each one of the ones on the screen right now, the entire thing is raised to the 0. Therefore the answer is 1. So now, look at the 7s I gave you across. I gave you a 7, I gave you a -7 in parentheses, and I gave you a -7 without parentheses. I love to do this with second powers, any power actually, but mainly squares and cubes and then zeros for sure, but any power for that matter, because it does matter, especially between these two over here, it matters. All right? So here, if I look at this, what's being raised to the 0 power in the first one? 7 to the 0, that 7 is. So there's nothing else there. Everything's raised to the 0, so the answer is just 1. Now we look at the -7 in parentheses right here. Since it's in parentheses, both the negative and the 7 are raised to the 0 power. Therefore, the answer is 1 because everything is being raised to the 0 power. But then you look at the one on the far right up here. -7 to the 0 power with no parentheses here. So if you recall our order of operations, PEMDAS, or please excuse my dear Aunt Sally, right? PEMDAS says parentheses, which I don't have here, exponents, which I do have, then multiply, divide, add, subtract. So the relationship between the 7 and the 0 is an exponent. The relationship between the 7 and the minus sign is multiplied. That's a negative times 7. All right? So we do the exponent first. We do this. That thing gives us 1, and then we have this negative out front. Okay? So that answer is -1 for that reason. Okay? This one equals -1. All right? This one equals -1 because you must do the 7 to the 0 power first and then apply the negative after the fact. All right? Because it is multiplied and the 0 is an exponent. So then that leads us to 38x to the 0 power. 38x to the 0 power. What's being raised to the 0 power? Be careful, only the x, because again, what is the relationship between the x and the 0? That's the exponent here, right, for PEMDAS, the e. What is this relationship, the 38 and the x? That's times. Remember in algebra, if you write a number times a letter, a variable, then it means times. And times is multiply. It comes after the exponent e in PEMDAS. Okay? So you have to do this first and get a 1. And then you have 38 times 1, which is what? 38. Right? Because it's not in parentheses, only the x is raised to the 0 power, and then you multiply it by the coefficient out front, 38. Same principle as this. The coefficient out here is just -1. All right? So then look at this next one, 38x in parentheses to the 0 power. All of this is in parentheses, so then the 0 power is applied to all of it, so the answer is simply 1. Do you see the difference between these two right here? Right? There's a difference. The one on the left, the 38, is not in parentheses, so you do the x to the 0 first, and then you multiply by 38. The one on the right, 38x, is in parentheses, so the whole thing is to the 0 power. That equals 1. All right, so let's look at some more of these. And what I want to do is kind of combine it with, recall the property for dividing like bases and use it to simplify the following. So combining like bases, if you have trouble with this, I have a video for that as well, combining like bases. So it's called properties of exponents, combining like bases. You take this here, x to the m over n, just means subtract the exponents, right? Just subtract the exponents. So if I do that, if I look at this here, if I look at this, these exponents here, this is going to be x to the 7 minus 7, which is x to the what? 0, which is 1, which is 1. And actually in that video, the dividing like bases video, I actually have an example of one like this thought about in a different way. So that may help you grasp it a little bit too if you go watch that as well. All right, so what if there's coefficients on it? It's still the same thing. If you have two things multiplied together here, right? This is multiply. That's the key. I have one term but two factors. 8 is a factor and y to the 11th is a factor. Okay? 12 is a factor. Y to the 11th is a factor down here. Again, this is one term. If you have one term over one term, that's important. If it's one term over one term, you can do what I'm about to do. If you start having pluses or minuses in the numerator at the top or the bottom of the denominator, then those rules change. You got to make sure that you understand one term over one term. If I do that, then I can take things that are similar and divide them out. What I mean is I can take the 8 over 12 and simplify that like I would normally have if I just had 8 over 12. And then I can take the y to the 11th over y to the 11th just like it's its own thing. And then I can go back and say, okay, they're multiplied, so I'll multiply them together. So here, let's look at this. What about 8 over 12? What do 8 and 12 have in common? Well, if I had 8 over 12, I'd say, okay, they got a 4 in common. 4 goes into 8 twice, and 4 goes into 12 3 times. So when I get ready to write this down, this is 2/3, right? So far. 2/3. And then here, y to the 11th over y to the 11th, that's going to be y to the 11 minus 11. So that's going to be... And if you want to, you say, I don't like the way you wrote that there. You could write 2/3 and y to the 11 minus 11 and not put it in the numerator of the fraction. That's fine. But if you multiply a fraction by something, that something is over 1, so it's really in the numerator. So however you choose to do that's fine, but either one of those is okay. And then just don't write a slanted fraction. We've talked about that several times in my videos. Right? This is 2y to the 0 over 3. But wait a minute, we said y to the 0 was 1, right? So this is really just what? 2/3. That's really just 2/3. So this is just a quick little video to help you out with something to the 0 power. Anything to the 0 power is 1. You just need to be careful what's being raised to the 0 power. All right?